You're standing at the edge of the Grand Canyon feeling absolutely tiny next to this massive natural wonder. The wind is whipping through your hair, and you're staring down into what feels like the Earth's deepest secret. Now I want you to take that feeling and multiply it by 10. Actually, scratch that. Multiply it by 100. What if I told you there's a canyon so enormous that it would make our Grand Canyon look like a small scratch on a sidewalk? We're talking about a chasm so wide you could fit the entire state of California inside it, and so long it could stretch from New York to Los Angeles and back again. This isn't some fantasy from a science fiction movie. This is real, and it's sitting right there on Mars, waiting for us to understand its secrets. Welcome to Valles Marineris, the most spectacular scar in our solar system. This isn't just Mars' version of the Grand Canyon, it's something completely different, something that challenges everything we thought we knew about how planets work and change over time. Here's what makes this story so fascinating. When scientists first discovered this colossal canyon back in 1971, they had no idea what they were looking at. The Mariner 9 spacecraft was just doing its job, taking pictures of the red planet's surface, when suddenly these images came back showing something that shouldn't exist. A canyon so massive that it defied explanation. You see, on Earth, we understand how the Grand Canyon formed. The Colorado River spent millions of years carving through rock, grain by grain, creating this incredible masterpiece. But Mars doesn't have rivers like ours. It doesn't have the same kind of weather, the same kind of geological activity. So how did this monster canyon come to be? That's where our story gets really interesting. Scientists have been scratching their heads for more than 50 years now, coming up with theories that sound like they're straight out of a disaster movie. Some think massive volcanic eruptions cracked the planet's crust like an eggshell. Others believe ancient floods bigger than anything Earth has ever seen carved out this enormous valley. And then there are those who think the entire thing was caused by the planet literally tearing itself apart. But here's the thing that gives me goosebumps every time I think about it. This canyon isn't just sitting there quietly. It's still changing, still evolving, still telling us stories about what Mars was like billions of years ago when it might have been a very different world. A world with oceans, with weather systems, maybe even with conditions that could have supported life. Every time we send a new mission to Mars, every time we get better images and more detailed measurements, we discover something new about Valles Marineris that makes the mystery even deeper. It's like reading a book where every page reveals a new plot twist. And just when you think you understand what's happening, the story takes another unexpected turn. So buckle up, because we're about to take a journey to one of the most incredible places in our solar system. We're going to explore theories that will make your head spin, discoveries that will change how you think about planets, and maybe, just maybe, we'll get a little closer to understanding what really happened on Mars all those billions of years ago. Trust me, by the time we're done, you'll never look at Mars the same way again. This red dot in our night sky isn't just a distant world, it's a planet with stories to tell. And Valles Marineris is its most dramatic tale. Now let me help you really grasp just how mind-blowing this canyon actually is. We're talking about something that stretches 4,000 kilometers from end to end. To put that in perspective, if you could somehow pick up Valles Marineris and drop it onto the United States, it would reach from the Atlantic Ocean all the way to the Pacific coast. Imagine driving from New York to Los Angeles and still not reaching the end of this Martian canyon. But it's not just long, it's incredibly wide and deep too. At its widest points, this canyon stretches 200 kilometers across. That's like looking across a valley and not being able to see the other side even on the clearest day. And when you look down, you're staring into an abyss that drops 7 kilometers straight down. That's deeper than Mount Everest is tall, except you're looking into the ground instead of up at the sky. Here's what really gets me. If this canyon existed on Earth, it would completely reshape our understanding of geography. Picture a chasm running from Canada down to Mexico, splitting North America right down the middle. That's the scale we're dealing with here. But here's where the story gets really interesting, and it involves a mystery that connects us to some of the most famous astronomers in history. The canyon gets its name from the Mariner 9 spacecraft, the brave little probe that first spotted this geological giant back in 1971. Before that moment, we had no idea Mars was hiding such an incredible secret. Now, This is where things get fascinating. Long before we had spacecraft, there was this passionate astronomer named Percival Lowell. Back in the late 1800s and early 1900s, Lowell was absolutely convinced that Mars was covered with canals built by intelligent beings. He spent countless nights peering through his telescope, sketching what he believed were artificial waterways crisscrossing the red planet's surface. Lowell wasn't just some amateur stargazer. He was a respected scientist who built his own observatory in Arizona. He was so certain about these Martian canals that he wrote books about them, gave lectures, and convinced much of the world that we weren't alone in the universe. The idea of civilized Martians became part of popular culture, inspiring everything from science fiction novels to radio shows that made people think Earth was being invaded. But here's the thing that makes you wonder. Was Lowell actually seeing something real? Not alien-built canals, of course, but maybe glimpses of this massive canyon system that we now call Valles Marineris. Through his telescope, with the atmospheric distortion and the limits of early 20th century optics, could he have been detecting hints of this enormous geological feature? It's one of those tantalizing questions that we'll never fully answer. Lowell died in 1916, more than 50 years before Mariner 9 would reveal the true nature of Mars's surface. He never got to see the real canals of Mars, not the artificial waterways he imagined, but this natural wonder that dwarfs anything we have on Earth. There's something beautifully poetic about this connection. Lowell spent his life dreaming of a Mars filled with engineering marvels created by intelligent beings. Little did he know that Mars really did have engineering marvels. They just weren't built by anyone. They were carved by forces so powerful and mysterious that we're still trying to understand them today. So what could possibly create such a massive scar across an entire planet? Well, the leading theory reads like a geological disaster movie, and it all starts with the biggest volcano in our solar system. Picture Mars, billions of years ago, a young, restless planet where titanic forces were reshaping the landscape on a scale that would make our worst natural disasters look like gentle summer storms. At the center of this drama stands Olympus Mons, a volcanic mountain so enormous that it makes Mount Everest look like a small hill in comparison. Now here's where the story gets really interesting. Olympus Mons isn't just big, it's almost impossibly massive. This volcanic giant rises 21 kilometers into the Martian sky and spreads across an area roughly the size of the state of Arizona. To put that in perspective, if you were standing on one edge of this volcano, the other side would be beyond the horizon, completely invisible to you. But here's the thing that scientists find most fascinating. All that volcanic material had to come from somewhere. We're talking about billions upon billions of tons of rock that erupted from deep within Mars and piled up into this colossal mountain. And that's where our story of Valles Marineris really begins. Imagine the planet's crust as a giant piece of glass. Now imagine placing something incredibly heavy on one part of that glass, so heavy that it starts to create stress fractures radiating outward from the point of pressure. That's essentially what many scientists believe happened on Mars. As Olympus Mons grew larger and heavier over millions of years, its immense weight began to crack the planet's crust like a spider web spreading across a windshield. But there's more to this story than just the weight of one massive volcano. Mars is fundamentally different from Earth in a way that makes this scenario even more dramatic. Here on our planet, we have something called plate tectonics. Essentially, our planet's surface is made up of huge puzzle pieces that slowly move around, bumping into each other and sliding past one another. This movement actually helps relieve pressure and stress in the Earth's crust. Mars doesn't have this system. Its crust is essentially one solid piece, locked in place with nowhere for the stress to go. So when enormous volcanic forces start building up pressure, something has to give. And when it finally does give way, the results are catastrophic on a planetary scale. Dr. Maria Rodriguez, a planetary geologist who has spent decades studying Martian geology, explains it this way. When you don't have moving plates to distribute stress like we do on Earth, unique processes take over. The crust can actually sink and collapse in ways that would be impossible on our planet, creating fractures that can grow into massive canyon systems. Think about it like this. If you keep pressing down on a piece of ice that can't bend or flex, eventually it's going to crack in a big way. That's what we think happened to Mars. The combination of volcanic loading and the planet's rigid crust created the perfect conditions for the formation of something truly extraordinary. But here's what keeps scientists up at night. This theory, while compelling, doesn't explain everything we see in Valles Marineris. Some parts of the canyon system don't line up perfectly with what we'd expect from volcanic stress alone. There are features that suggest water might have played a role, and other geological signatures that hint at processes we don't fully understand yet. It's like having most of the pieces of a jigsaw puzzle, but finding that a few crucial pieces seem to belong to a completely different picture. The volcanic collapse theory gets us most of the way there, but Mars clearly has more secrets to reveal about how this incredible canyon came to be. Picture this. You're standing on the rim of Valles Marineris, gazing across a canyon so massive it defies imagination. But here's the mind-bending part. What if I told you that billions of years ago, you might have been standing at the edge of a churning, angry ocean instead? This isn't science fiction. This is one of the most captivating mysteries in planetary science, and it's changing everything we thought we knew about the red planet. Close your eyes and imagine Mars not as the dusty red world we know today, but as a planet painted in brilliant blues and whites. Scientists have discovered compelling evidence that ancient Mars once harbored vast oceans across its northern plains, with shorelines that tell a story of catastrophic events. These weren't gentle, Earth-like seas. They were the stage for some of the most dramatic geological events our solar system has ever witnessed. The story begins around 3.5 billion years ago, when Mars was a very different world. The atmosphere was thicker, temperatures were warmer, and liquid water could exist on the surface. But Mars held a secret that would reshape its entire landscape in the most violent way imaginable. Here's where our story takes a dramatic turn. Two massive meteorites, hitting the planet millions of years apart, triggered a pair of mega tsunamis that would make any disaster movie look tame. Think about the most powerful tsunami you've ever heard of on Earth. Now multiply that force by hundreds. The first impact sent shockwaves rippling across the Martian Ocean. Imagine walls of water rising nearly 400 feet high, that's taller than the Statue of Liberty, racing across the planet at speeds that would make a jet plane jealous. These weren't ordinary waves. They were liquid mountains carrying everything in their path. Boulders the size of buildings, sediment, ice, and debris from the impact itself. But Mars wasn't done with its cosmic punishment. Millions of years later, a second meteorite struck, unleashing another tsunami that carved even deeper scars into the planet's surface. The geologic shape of what were once shorelines provides evidence of these catastrophic events, like a crime scene written in rock and sediment. Now here's where Valles Marineris enters our story. As these massive waves surged across Mars, they didn't just wash over the surface. They carved, scraped, and gouged the planet with the persistence of a cosmic sculptor. The canyon system became a highway for these ancient floods, with water rushing through at speeds and volumes that boggle the mind. Evidence shows that water from the canyon system flowed into the lowlands, possibly contributing to ancient lakes or oceans. Picture the Grand Canyon, but instead of the gentle Colorado River meandering through it, imagine torrents of water carrying entire mountainsides, flowing with the fury of a planetary tantrum. The walls of Valles Marineris still bear the scars of this ancient drama. Layered terrains, ancient river valleys, and evidence of massive landslides tell the story of varied climatic epochs when water flowed freely across Mars. Each layer is like a page in Mars' autobiography, written in stone and sediment. As you stand at the edge of this magnificent canyon today, you're looking at the remnants of one of the most incredible transformations in planetary history. The oceans that once covered nearly a third of Mars didn't just disappear. They were absorbed into the ground, frozen at the poles, or lost to space as the planet's atmosphere thinned and temperatures plummeted. But here's the truly fascinating part. Those ancient waters didn't just carve Valles Marineris. They may have created the perfect conditions for life. The evidence of ancient oceans offers insights into environments that could have been conducive to life. Imagine microbial organisms riding those tsunami waves, spreading across the planet, adapting to new environments carved by cosmic catastrophe. The more we learn about Mars' watery past, the more we realize how different our neighboring planet could have been. If those impacts hadn't occurred, if the atmosphere had remained thick, if the magnetic field had persisted, Mars might have remained a blue world. perhaps even harboring complex life forms that could have gazed up at Earth the same way we now look at Mars. Today, as our rovers crawl across the Martian surface and our orbiters map every crater and canyon, we're not just exploring a dead world. We're investigating a crime scene on a planetary scale. Every rock sample, every photograph, every measurement brings us closer to understanding one of the greatest transformations in our solar system's history. The next time you look at Mars in the night sky, remember, you're not just looking at the red planet. You're looking at a world that once knew the crash of waves against ancient shores, the fury of cosmic impacts, and the flow of rivers that carved canyons on a scale that dwarfs anything on Earth. And who knows? As we continue to explore and eventually set foot on Mars, we might discover that this ancient watery world holds even more secrets than we ever imagined. The story of Valles Marineris and Mars' lost oceans is far from over. It's just beginning to be told. Here's something that might surprise you. Right now, as you're reading this, Valles Marineris is changing. While we often think of Mars as a frozen, dead world, this massive canyon is actually very much alive, constantly reshaping itself through forces that would seem impossible on Earth. Imagine standing on the rim of Valles Marineris during one of Mars' legendary dust storms. The wind doesn't just blow, it roars across the landscape with a fury that makes Earth's hurricanes look gentle. These aren't ordinary breezes. They're katabatic winds with intense, clear-cut downslope circulations that race down the canyon walls like invisible waterfalls, carrying particles of sand and rock that act like nature's own sandblasting equipment. Every grain of dust becomes a tiny chisel, every gust of wind a sculptor's tool. The canyon walls, already ancient beyond imagination, continue to be carved and polished by this relentless atmospheric artwork. It's as if Mars has been running the world's longest art project, and we're just now beginning to appreciate the masterpiece. But here's where the story gets really fascinating. The wind isn't working alone. It has a partner that makes this geological dance even more remarkable. During Martian winter, something magical happens. Carbon dioxide ice, what we call dry ice, covers the terrain, transforming the red landscape into something that looks almost like a winter wonderland. But this isn't the gentle snow we know on Earth. This is frozen carbon dioxide that sublimes directly from solid to gas, creating its own weather patterns and erosion processes. Picture this. As the Martian seasons change, this dry ice doesn't melt like water ice would. Instead, it transforms directly into gas, creating powerful jets and flows that carve new channels and reshape existing ones. It's like watching a time-lapse video of Earth's erosion, but sped up and operating on principles we barely understand. The combination of these carbon dioxide ice formations and the powerful winds creates what scientists call a living laboratory of geological processes. Channels appear to have been formed by water or carbon dioxide in ongoing processes that continue to puzzle researchers. Now, here's something that will make your head spin. Some sections of Valles Marineris have cliff faces that lean at 60-degree angles. To put that in perspective, that's steeper than the face of the Empire State Building. On Earth, such steep rock faces would collapse under their own weight faster than you could say landslide. So why don't these impossible cliffs just tumble down? The answer lies in one of Mars' most helpful characteristics. Its gravity is only about 38% as strong as Earth's. What would be catastrophically unstable on our planet becomes surprisingly stable on Mars. It's like having a cosmic safety net that allows geological features to exist in ways that defy our earthly experience. But even with this gravitational advantage, the cliffs don't stay unchanged forever. Landslides in the area probably were gigantic wet debris flows, with one landslide complex generating a channel that extends for 250 kilometers. These aren't small rockfalls. They're landscape-changing events that create new valleys and reshape entire sections of the canyon. The most remarkable thing about all this ongoing activity is how it reveals Mars as a world still very much in the process of becoming. While we often think of planets as finished products, Mars shows us that geological time moves at its own pace, and what seems permanent to us is actually fluid over the vast scales of planetary evolution. Dunes and wind streaks form behind obstacles, creating patterns that shift and change with each Martian season. The canyon floor becomes a canvas, where wind and ice paint new designs, while the walls continue their slow but inexorable transformation. Think about it. Every image we receive from Mars orbiters captures a moment in this ongoing sculpture project. The Valles Marineris we see today is different from the one that existed when the first spacecraft photographed it decades ago. And it will be different again when future explorers arrive to walk its rim. What makes this ongoing transformation so captivating is how it challenges our understanding of planetary evolution. Mars isn't just a museum of ancient processes. It's a living laboratory where we can observe geological forces that operated on Earth billions of years ago, but under conditions that exist nowhere else in our solar system. Glaciers probably helped with the carving, and signs of acid rock interaction suggest that giant ice formations may have helped carve at least some of the extensive network of channels. Even the mineral deposits tell stories of ongoing chemical processes that continue to reshape the canyon's character. As our robotic explorers continue to monitor these changes, and future human missions prepare to witness them firsthand, we're reminded that Mars isn't just a destination. It's a world still actively writing its own story. And Valles Marineris, with its impossible cliffs and ever-changing landscape, might just be the most dramatic chapter in that ongoing tale. The next time you look at images of Mars's Grand Canyon, remember, you're not just looking at ancient history. You're witnessing a world that's still very much alive, still sculpting itself with tools we're only beginning to understand, still surprising us with the artistry of planetary evolution in action. As we reach the end of our journey through Valles Marineris, I want you to imagine something extraordinary. Picture yourself standing at the edge of this magnificent canyon, not as a distant observer looking at photographs, but as a human explorer breathing recycled air inside a spacesuit, gazing across a landscape that holds the secrets of an entire world's history. Because that's exactly what Valles Marineris is. It's not just a canyon. It's the greatest geological archive in our solar system, a library written in stone and sediment that contains chapters about ancient climates, vanished oceans, and the tantalizing possibility that life once flourished on the red planet. Every layer of rock in those towering canyon walls tells a story that scientists are only beginning to read. Think of it like this. If Earth's Grand Canyon reveals millions of years of our planet's history, then Valles Marineris holds billions of years of Martian secrets, each stratum a page in a book we're just learning how to read. Right now, as you're reading this, our robotic explorers are adding new chapters to this story. The Perseverance rover, searching for signs of ancient microbial life and collecting core samples of Martian rock and soil, is uncovering clues about Mars' past habitability. Meanwhile, the ExoMars mission has made a discovery that would have seemed like science fiction just a few years ago. They found the central part of Valles Marineris packed full of water, far more than expected, much like Earth's permafrost regions where water ice persists under dry soil. Imagine that. Beneath the dusty, seemingly lifeless surface of Mars' grandest canyon lies a hidden reservoir of water ice. It's like finding a secret basement in an ancient castle, except this basement might hold the key to understanding whether Mars could have supported life. But here's what really gets exciting. Every answer our missions discover leads to 10 new questions. ExoMars is specifically designed as a search for life mission, targeting sites with evidence of past or present habitable environments. Each soil sample, each photograph, each measurement brings us closer to answering one of humanity's most profound questions. Are we alone? The ExoMars rover is equipped with tools that can drill deeper into the Martian surface than any previous mission, reaching layers where organic compounds might have been preserved for billions of years. It's like having a time machine that can peer into Mars's ancient past, when the planet was warmer, wetter, and possibly teeming with microscopic life. But the real magic happens when we combine all these puzzle pieces. The ancient tsunami evidence, the ongoing erosion, the hidden water ice, the mineral deposits that suggest past habitability. They're all connected in ways we're only beginning to understand. Now, let me paint you a picture of the future. Valles Marineris is considered ripe for human exploration that can uncover the planet's history and its capacity to sustain microbial life. One day, perhaps sooner than we think, human explorers will walk where our rovers roll today. Imagine astronauts rappelling down those impossible cliff faces, their boots the first to touch rocks that have waited 4 billion years for this moment. They'll collect samples that no robotic arm could reach, make observations that no camera could capture, and ask questions that no algorithm could formulate. These future explorers might set up research stations on the canyon rim, watching the Martian sunrise paint those ancient walls in shades of red and gold. They'll study the layers of geological history with their own eyes, perhaps discovering fossilized evidence of ancient life or uncovering clues about how Mars lost its magnetic field and atmosphere. But here's the most remarkable part of this story. You're part of it. Every time you look up at Mars in the night sky, every time you read about a new discovery, every time you wonder what secrets that red dot holds, you're participating in humanity's greatest adventure of exploration and discovery. The children in classrooms today might be the ones who take those first human steps into Valles Marineris. The questions we're asking now about ancient water, past habitability, and the possibility of life will be answered by missions that are still being planned, by technologies still being invented, by dreamers who haven't even been born yet. Mars isn't just our planetary neighbor. It's a mirror that reflects our own world's past and possibly its future. As we study how Mars lost its atmosphere and water, we learn about the delicate balance that keeps Earth habitable. As we search for signs of ancient Martian life, we gain perspective on how precious and possibly rare life truly is in the universe. The Valles Marineris story is still being written, and each new mission adds another chapter. The questions we haven't answered yet are perhaps more exciting than the ones we have. What will future explorers find in those deep canyon shadows? What stories will those rock layers tell when we can finally read them with human eyes and touch them with human hands? The greatest adventure in human history isn't something that happened in the past. It's happening right now, and it's pointing toward a future where the Grand Canyon of Mars becomes as familiar to us as the mountains and valleys of our own world. That future is closer than you might think, and it's being built one discovery, one mission, and one question at a time.